I'm Monica Bushnov. For creating a robot, we have to choose robot from base nodes. We have to add it, and then we have to go to the children. We have to choose shape from the base node. We have to add it, and then we have to choose behavior appearance, and then the color. Here I'm choosing yellow for my robot, and we have to make the metalness 0.5, and then geometry. We have to choose a box shape for our body part, and then we have to resize our robot, and here I'm choosing 0.03 and 0.11. So here is our body, and then we have to name the shape as body. And go to the bounding object and use the body shape, and go to the physics and use add the physics. Okay, here the body is completed. Now for the wheels, we have to go to the children again. We have to choose a hinge joint for making a wheel. So add it, and then go to joint parameter, hinge joint, and go to the device. We have to choose a rotational motor for our robot wheel, and for endpoint we have to choose solid, and go to the children. We have to choose shape, and in the shape we have to appearance as before. For wheel we are choosing black, and geometry cylindrical shape. We have to change the height and radius 0.02, 0.04 for the geometry part, and we have to just rotate the position of the wheel. For translation, we are putting x value 0.0499, y is minus 0.00654, and for z we are choosing 0 minus 0.00256, and for rotation we're choosing 0, 1, and it will be 1.57, and for the scale 0.61, 0.61. Okay, so here our one wheel is ready, and we have to add the next wheels.
Assalamualaikum, I'm Aisha Rabbani, and now I'm going to add distance sensors to the robot. So this is the distance sensor to the left. As you can see here, I have added 2 distance sensors and this is the code. So now I'm going to simulate this robot. So the robot is following the line. So this was it.
Hello, I'm Shafkat. So right now I'll be explaining the code of the robot. So at the beginning in line 3, we take a default time for the time step, a default value for the time step and constant for the max speed. Then for the motor wheels, we use the get motor function. Using the get motor function for the left wheel, we get the value for the left wheel, and similarly for the right wheel we also get the value of the motor for the right wheel, and then we set the position and velocity for both the wheels. For left wheel we set position, uh, we set a position. For the right wheel we set a position, and for the left wheel we set the velocity 0 0.0. For the right wheel we set the velocity 0 0.0. Then moving on to the camera, to the IR code, we use the get device function, uh, get device function whether and determine whether the robot would turn left or the sensor would turn point left or right, and we use the enable function. Then moving on to the simulation, if the time step is not equal to 1, then the following loop follows. So uh, right now we what we do is we multiply the max speed with a value 0.25, which is basically calibrate, and therefore we multiply it with a constant 0.25. Now if the left IR value is less than the right IR value and the value is between 500 and 1000, we basically calibrate for and put these values. So then the robot would go left, and else if the right IR value is greater than the left IR value and the right IR value is between 500 to 1000, the robot would go right. And this is basically our code. And however, and at the beginning, in line uh, 27 to 29, the for if the following thing happens, by default the robot would go forward, which means the left speed and the right speed operates at the same time. So thank you.